Example, prove that a 1, 2, b 5, 6, c 7, 4, and d 3, 0 are the vertices of the rectangle. In order to prove that if these coordinates are the vertices of rectangle, what I'm going to do, I'm going to consider a graph and then I will graph all these points. So this is my graph. Let this is my x-axis and let this is my y-axis. Let's consider point A. So as you can see, my x is 1 and y is 2. So I will go 1 and then 1, 2. So this is my point A. Now let's consider point B, which is 5, 6. So my x is 5 and y is 6. So I will go 1, 2, 3, 4, 5 and then 1, 2, 3, 4, 5, 6. And this is my point B. Now let's consider C, which is 7, 4. So my x is 7 and y is 4. So I will go 1, 2, 3, 4, 5, 6, 7 and then 1, 2, 3, 4. And this is my point C. Now my last point is G, which is 3, 0. So my x is 3 and y is 0. So I will go 1, 2, 3 and this is my point D. Now what I'm going to do, I'm going to connect all these points. So I will connect A with B and then B with C, C with D, and then point D and A together. Now, if you remember the property of rectangle, which states that opposite sides are equal and congruent, or I should say congruent. So if I can prove that AB is congruent or equal to CD and AD is equal to BC, then we will prove that one property of the rectangle satisfies. And then we need to talk about another property, which is basically diagonal. So let's first talk about the sides AB and DC or CD. So the distance formula that we are going to use is basically D is equal to square root of x2 minus x1 square plus y2 minus y1 square. And what I'm going to do, I'm going to consider AB first. So let's consider AB. So I'm going to just draw a line so that I can separate AB and CD. So this is a line. Now let's consider point A, which is 1, 2 and B is my 5, 6. So I'm considering AB. Now let's consider CD. So this one and this one. So let's consider these two sides. So I'm going to consider CD now. My C is 7, 4 and my D is 3, 0. So as you know, my first point is x1, y1 and my second point is x2, y2. For both the 2 points I'm doing together. So, and for point C, this one is x1, y1 and point D will be x2, y2. Now let's use the distance formula. So I will write AB is equal to square root of x2 minus x1 square. So I will write 5 minus 1 square. So I'll write 5 minus 1 square plus 6 minus 2. 6 minus 2 square. And 5 minus 1 is basically 4. So I will write a square root of 4 square plus 6 minus 2 is also 4. So I will write 4 square. So if I simplify further, I will write 4 square as 16 and then this 4 square is also 16. So I will get AB is equal to square root of 32. Now let's consider CD. So my CD will be square root of x2 minus x1. So I will write 3 minus 7 square plus y2 is 0. So 0 minus 4 square. And as we know, 3 minus 7 is basically negative 4. So I will write negative 4 square plus 0 minus 4 is also negative 4 square. So as we know, negative 4 square is 16, and this is also 16. So I will write 16 plus 16. And as we know, 16 plus 16 is 32. So I will write CD is equal to square root of 32. So as we can see, AB and CD is equal. So I will write AB is equal to CD. So this is our first pair of congruent side. Now let's consider side BC and AD. So I will take B as 5, 6 and C as 7, 4, and on this side I will consider AD. So I will write D as 3, 0 and A as 1, 2. So let's first solve for BC. So this is my x1, y1, and this is my x2, y2. So I'm going to find the length of side BC. So I will write BC is equal to square root of x2 minus x1. So I will write 7 minus 5 square plus 4 minus 6 square. And we know that 7 minus 5 is basically 2 square plus 4 minus 6 is also negative 2. So 2 square is 4 and a square of negative 2 is also 4. So we will get a square root of 8. So our BC is basically a square root of 8. Now let's try to find DA. So this is my x1, y1 and this is my x2, y2. So I will write DA is equal to square root of x2 minus x1. So I will write 1 minus 3 square plus y2 minus y1 is basically 2 minus 0 square. So this is DA equals to square root of, we know that 1 minus 3 square is basically negative 2 square plus 2 minus 0 is basically 2. So I will write 2 square. So negative 2 square is 4 and the square of 2 is also 4. So I will write my DA is equal to square root of 8. So as you can see, my BC is root 8 and my DA is also root 8. So I can write over here as BC is equal to DA because both of them are congruent. So this side is congruent to this side. Now what we need to do, we need to prove that this diagonal, which is basically our BD, is equal to AC. So let's find AC first. So my A is 1, 2 and my C is 7, 4. And at the same time I have my B, which is 5, 6 and my D is 3, 0. Now let's find AC on this side. So I will do AC is equal to, this is x1, y1 and this is x2, y2. So I will write x2 minus x1, so 7 minus 1 square plus y2 minus y1 is basically 4 minus 2 square, because you can see y2 is 4 and x1 is 2. So that's what I have over here. Now if I simplify further, I will get 6 square plus 4 minus 2 is 2 square. And 6 square is basically 36 plus 2 square is 4. So 36 plus 4 is basically 40. So I will write square root of 40. And this is my AC. Now let's find BD. So this is my x1, this is y1, this is my x2, and this is y2. So my BD will be square root of x2 minus x1. So I will write 3 minus 5 square plus 0 minus 6 square. 3 minus 5 square is basically negative 2 square plus 0 minus 6 is basically negative 6 square. So square of negative 2 is 4 and square of negative 6 is 36. So 4 plus 36 is basically root of 40. And this is my BD. So as you can see, my AC is equal to BD, which simply means that my diagonal AC is equal to my diagonal BD. Now let's see what we have proved so far. So we proved that opposite sides are equal and this diagonal is congruent to this diagonal. And this is how we will use the distance formula to solve the mathematical problems.